So in preparation right now, I made this little list. What I did here, I put aside, these are the PNPs transistors. And here on the other side of the table, just to be sure, I will not mix them. The NPNs, these guys, I've tested them. I don't have it that many. So these are the PNPs, as you can see there, is written there. It's kind of on the bottom, but they are, yeah, they are scrapped. Probably a few, like 4, maximum 10, but no, not really. Probably 4 or 6 are brand new, bought from the store, electronic store. Sometimes a very long time ago, but the large majority of them are scrapped. And also, by the way, if you are curious how everything is looking, here are my drawers, and here is my box with the NPNs. Well, half of it is full, but also very weak. These ones, they look like they are big and strong, but they are weak and shitty, like the other ones. And I should use them somewhere. So what I did here, I double check. After I choose a couple of them, after I tested a couple of them on that device there. It's called, it's a transistor tester, pretty much. SR. It's called there. That's the name of it. GM328A. That's the name of it. And I tested a couple of them, actually more than 4, until for the PNPs here, until I reach for all 4 of them emitter base collector on this specific pins as when you keep it like this. Let me actually show it. So when you keep it, with the flat up and the legs not towards you, but from you towards exterior, and like this, exactly like this, in this position, and all of them like this is the way I've inserted them there in that pin holder, green pin holder, and socket, whatever it is. So until I find all these 4, which are very, very different between them actually. This one, let me actually show it to you. You see, is 310-7E. That's a Russian letter E, and this guy is only having one green dot there, and this is it. That's all the marking it has. Only one green dot. That's the way they were marking them. And this guy also is having some color dots on it, as you can see, white on top and yellow on the flat side. And also this guy here. This is a known. This one you know it. This kind of type, and is not focusing. Okay. Beche BC558 or 9. Let me actually look. 9. Yeah, 9. BC559. So all these 4 guys here, they all have emitter base collector in this arrangement of the pins. The NPNs also are different between them. I believe I have 2 of them the same, but 2 of other are not the same. Also scrapped, very much scrapped. And also this, a little bit of weird pin arrangement. Usually how I'm used to, one second, not that one, this one. Usually this is how I'm used to it, collector base emitter for the NPNs. Yeah, well, it says there, NPN. So it should have been like this. Collector, emitter, and base for that guy, but it's not. It's having the base on the side and collector in the middle and emitter on the other side. So you see, this is the proper way, or at least the way I'm used to. I learned them by heart in this configuration, collector, base, emitter. But there are some very strange other ones with very different pin assignment. And pretty much this is it about the transistors that I'm using them. Very, very scrapped ones. And this is the diagram that I put it here on paper. It's good to have it for filming, for showing it to you. As you can see, here is the input, 10 kilo on both of them, of those bases of them. And the output is coming from the linked emitter. And pretty much this is it. And it should do the thing. Now I will have to pair them and actually make the board. I only prepared the cardboard here that I will construct the thing onto it. And pretty much this is it for this part. I think you will appreciate some update. What I did here is the testing when I tested all the transistors. Here is actually the circuit that I have to build, and it is exactly this. I don't know, component now comprised from 2 transistors, back to back or head to head, kissing each other. And this is the shape. I was thinking about it, and their corresponding pin assignments. And this is how they will actually be linked, all the pins. So this is what you're seeing here is the plan. Okay, here is the plan, and I'm following it step by step. And right now, while I'm filming this and presenting it, originally I put some white paint pretty much all over the transistor, especially on the round side here. But and then I glue them with shoe glue. It's called Renandels. I can show you actually. There's a Romanian-made shoe. It's a glue for shoes. Very very sticky and very hard when it's when it's getting hard is very strong, and also very rubbery as well, like a very hard rubber it became in the end. And I wasn't really satisfied because plastic glued by other piece of plastic is not really safe. And then I thought on I think about a bit more, and I have this shrinkable, heat shrinks tubes, and I have some large diameter here, and I use this large diameter that I'm holding right now. The rest are small diameters. I don't have that many, but I have something. It's not yeah. And I cut a little bit of shrink tube. The diameter of the shrink tube was a little bit less than smaller than these two put together here, and I didn't have to shrink. I didn't have to apply any kind of heat to the shrinking tube because it is rubber, like a rubber, and it kind of forced. I had to force it very very hard. I had to force it onto these two back-to-back transistors. I even had to file a little bit the back of some transistors. I believe this is more obvious here. You can see the round part is not round anymore; it's a little bit flat, and I file it only to have the chance to put this rubber heat shrink around them. And I really don't have to apply heat to it, but if it's absolutely necessary, yeah, I can come back and apply heat. But for now, they are pretty good. They are pretty good welded together like this, very solid. And also they have some glue on their faces between them, the shoe glue that I used before, and it should be solid enough. They are kind of solid. And the white mark that I have there are the PNPs only, and one PNP and one NPN, not to confuse any of them. And yeah, it's looking fine so far. And we will see later after I will actually make all the links that I have to make them. I will also have to include a resistor there for the common base, like you're seeing here, the 10 kilo there. And we will see. But so far, I'm pretty happy with this. How I catch them, how I make them together so far. All right. So I managed to bend everything. Let's see if it's focusing. Good. Bend and also soldered the pins exactly as I'm drawing it here. And let's see, it's like this. You see? And here is the base that 10 kilo will be linked or soldered to it, this diagonal pins, and the rest are, as you can see there. And if I'm rotating it like this, on the top the white marked transistor is the PNP, the bottom is the NPN. And here is actually how you are seeing it from the top view. This is from the bottom from the pins view, as you can see. I corrected it there. Originally I said top view, but not correct. And this is how you are seeing it here. Pretty much a little bit of diagonal pins there. That's the base, collector, and emitter. But I don't like it because in this position, because the positive is down and the negative is up. So I have to inverse it like this, as the rest are. And right now I made as many necessary drawings until it's convenient for me and clear enough. So right now I rotated it 180 degrees. Bottom up pretty much, so this white mark is down, which is PNP. I also specified there PNP, and there is NPN on the top. And here is the output. Here is the diagonal pins, which is the base, and two collectors, one to ground, one to positive, and pretty much that's it. This is not a module. This is a component right now. The new component that I created. It's a binary bit, and this is how it's looking a binary bit in reality. Well, a bit big, but it is. Binary bit. Binary bit, it means, for those who are watching my videos and don't catch it from the beginning or all of my discussions before, a binary bit is either 0 volts, extreme 0 volts, and extreme 5 volts, but nothing really in between or in air or floating. So either is 0, which is 0 volts, or 1, which is 5 volts, but nothing floating, nothing in between, in air. Pretty much that's the role of this little circuit I have there. And the components are done at this point. Next, I'll have to make the actual board with all the pads on which I will have to solder these new components, and also following the schematic that unfortunately I have it on my phone. I cannot show it on the paper, but you've seen it on Proteus simulation, and I'm following exactly that circuit that I simulated there in Proteus. So yeah, I hope you like it. I definitely like them. It was hard to make them. It wasn't easy, but yeah, it's cool. It is cool. It's very cool. All right, I made the layout. This will be the board for this binary bits, and here will be the inputs, which will come from there. All these 4 wires will be linked to these pads. These pads will go to the resistor, which is this little circle here. Represents the resistor is staying vertically, linked to the base there of this component, of this bit, binary bit component, and negative, positive, and this is the output from a side. And this is the positive rail, this is the negative rail. That will link everything together. And all these four outputs will be here. Let me actually point. So here on these pads, I will take out these diodes. I will also take out these resistors because they will not be needed anymore. On pretty much like that, kind of probably here. Yeah. So I will elongate. I will make it a bit more longer. And as you can see, here they are. I'm very, very extremely curious. You have no idea how curious I am. How will they work? If they will actually do the job as predicted and as simulated in the simulator. So pretty much, as you can see, this width of this paper here is kind of smaller than the width of that cardboard. So here I had to squeeze together everything, but in reality it will be a bit more space with it there than here. But here is the idea, the layout that I will follow. So that's the thinking, that's the planning, and it will be done. It will be done. No matter, one more point I want to add, no matter how many times I'm switching around, playing with the component, the idea is to get happy with the final version and to be comfortable. So, finalmente, I start the cardboard here, exactly like there, and I took the measurements, and it is fitting absolutely perfectly there, and well, like that. Probably this pin here, it will be bent up, and I have some okay distance between the components, which is good. So this pin will be bent up, not to interfere with other stuff that is there. And you see, it's let me center it a little bit better. It's pretty okay. It's pretty good. And from this bended pin, it will be a wire to those pads there, and pretty much this is it. Cool, no? It will be awesome. It will be awesome. All right, right. I didn't solder them. They are floating there. They're not doing anything yet. This is like a pre-visualization before to see how they will actually fit there, and it's a good test if the component is fitting, because this is a very new strange component that I made. And as I said, I bent that pin to actually make room and not be any problem there. There is sufficient space between them, which is very good as well. One thing that I completely overlooked, I didn't make a breadboard test of this thing, and yeah, I have no idea what to say at this point. Really, I am a bit perplexed. I have no idea. What I have here, this one with a silver face, is the PNP, and yeah, and the top one that is a black, is having a black face, is the NPN. And I made all the wiring like it's here, and this is the result. If I'm putting a 10 kilo to the positive rail, that's the positive rail here in the margin. The LED is lighting, but if I'm taking it out, pretty much maintaining it in air right now, the LED stays off. So this pin of the resistor is not connected to anything, is practically in air, floating. But if I'm slightly touching it, you can see, well, the camera is seeing a shimmering, but the naked eye doesn't see anything. I cannot see with my naked eye anything. That's interesting. And so it's very sensitive to positive voltage, I suppose. And if I ground this resistor, if I'm putting it to negative here, there, so there is the negative, the LED stays off. This is the positive of the LED here, the positive pin, and that is the negative. As you can see, that is the negative rail, which is this one, and that is the positive rail here, the second one. But if I'm doing something interesting, check this out. Of course, this is actually the configuration that I will use it here. But if I'm turning this LED around, I'm putting it with its positive. The bent pin is the positive pin of the LED on the positive rail, and the negative here is on this resistor. This resistor of the base is connected to the negative rail right now, and it is conducting through the PNP here on the bottom. But if I'm lifting it up, nothing is conducting. If I'm letting it in air, floating, and if I'm touching it exactly the same sensitivity as before, and if I'm connecting it to the positive right now, there, the LED stays lit. Of course, this is not the configuration that I will use like this, positive to negative, surging through the negative transistor here, the PNP. But it is interesting, configuration. This is the way I will use it, so I will put it back as it was before. Well, there. So now it's connected to the positive here, and the LED is lighting again. I have no idea what to think about it, because I observed something. To this transistor, for this transistor to be activated, it needs this resistor to be actually to the zero, and when this is positive, it will activate only this transistor. And when this pin here will be 0 volts. I'm not sure if that will actually switch to 0 volts. those pads are floating. I bet on the floating that they will float. I really hope they will float. If they will not float, or not 0 volts or a small voltage here, like 1 or 2 volts, this thing will not work, and I am a bit worried right now. I don't know. It worked in simulation, but here in reality, I really don't know. Probably I should add a pull down to the negative resistor somewhere on the emitter, probably. I don't know if this will not really work. Or here, actually, on the base, a pull down, you know, like probably another 10 kilo or 20 kilo or 100 kilo, a pull down to actually ground and maintain as negative that output, which is that LED in this configuration here. Yeah, I will. That's a bit new for me. I don't know what to say, but for now, I was playing with how they should be there. And this is how the resistors on the common base are looking like. Come on, focus, motherfucker. And that's how the soldering is. Also here, I'm using my vise, my trusty vise here. It's a very small vise, and that's how I'm holding. And the soldering, this is already soldered. This was the last one that I soldered. Come on, focus where I want you to focus. Yeah. And pretty much this is with the resistors. I find 10 kilo resistors for each of the bases, and they are all the same. Yeah, you can see there. That one. Yeah, pretty much. I've also added the pads here, long pads. This will be the negative, this will be the positive, and these 4 of them are the signal that will be linked to each of the resistors that I just shown, and we will go from there. After I will actually mount them. They are pretty thick, these pads, because as you can guess, this was a circle, a small disc of copper actually. It was like a screw or like a button, and I cut it with my cutters here. These cutters that I'm having them from the 90s probably. I had to screw this a lot to tighten it, and because it was loose a lot of the time, and but now when it's properly screwed, it's not having that retracting spring good anymore. It's too tight right now, but it's cutting perfectly. It's not bending when it's cutting. That was the biggest problem what he had, and I thought yeah, I should throw it away, but let me try to find a solution, and that was it. Tighten it was you know, when it's loose, it's having a gap, and having a gap is bending the material when it's pressing, but when it's perfectly flush, it's actually cutting, and it's cutting extraordinarily good, even thinner and even very thick. This is quite thick material that I have here, these pads. So pretty much this is it for this part. So it didn't work. I managed to make the board, no problem. And I bet, I'm sure it is functioning properly by its own, but what I am thinking, so everything is staying lit, sign that something is not going to negative correctly, to negative rail, to 0 volts, something, either this outputs are not going to negative, or the inputs from the wires. And I'm right now it's not working at all there, but if I'm resetting the positive from here, so if I'm doing this, that will start work on everything else, and if I'm putting it again, it will kind of work. It's like you see, and it's always stopping at there, and it's like that. The rest of the circuit is fine, I guess. Very diminished, very low intensity for some, even for this yellow LEDs that you're seeing here. Yeah, I see there a problem, but if I'm doing this, yep, it resolved itself. Sometimes I get some problems there in the end, but if I'm knocking it out, that's the solution. And this might appear to be very bright, but it's not really. And also the white LEDs, they're all very dim. So the sign that there is not much current left to flow for everything, and it's not really optimized in any way. What I did here, there are too many boards pretty much, and for some reason it should have, you know, this kind of source is giving me like probably 1 or more amps, and it is not really eating, I don't know, probably 100 milliamps, only this side of the circuit. But with this board here, probably this is I really don't know. I believe it's, maybe this chip is damaged somehow, and is eating a lot of current. I have no idea. I didn't test it yet. I'm also believing that maybe these 4 lines here are not actually, this might be the actual cause of the problem. These 4 lines of data of signal that are coming from there are not properly grounded. There is some voltage, even if these LEDs are off, there is some voltage left there somehow. I don't know, but it is influencing this pair of transistors that I have here, these bits, and after them is this is reading as high here for some reason, and not reading as low, because if it was reading low, everything was not staying, it was staying off, but something somewhere here is reading as high. I did the test again actually, but this time is a real short, not like before, because I don't really have a resistor, so pretty much is a short between positive and negative, and everything is shutting off, kind of. That is shutting off. This is diminished considerably. You see, I'm doing this, and you see when I'm doing to the negative here, from this pad to the negative rail that I have here, or from any other pads, because I did test them all, and if I'm putting to negative, it is clear short. And if this resistor is a little bit positive, it will keep open the NPN, which is linking the positive to the output to here, and pretty much I'm shortening the positive through this output to the negative when I'm doing this. But luckily I don't have, there is a lot of current surging through all this circuit, and the short is not that great, so nothing blows up, but it's not good if I'm doing this short here. That's a very big problem. So pretty much if this lines are 0 volts, like exactly 0 volts and not something else, a little bit higher, which it is the case right now. I'm afraid it is. I didn't really account it. I didn't really think of it. I was only thinking on the outputs here and the input for the chip, but I was trusting this lines will be 0 volts, and also the simulator gave me some hope, and yeah, shit. If I'm shortening the input here to the 0 volts, if I'm doing this, so there's nothing happening. I should have seen some behavior, and maybe now, yeah. Maybe I'm not making the contact there, but it is pretty much like, yeah, you see, that is not working, and that is working, but that is not working. And yeah, no, this is an error actually, when this is not working, whatever I'm doing here, and I have to reset it from the positive here. And this, and if I'm taking it out from the positive and putting it in, it's kind of working again. But this is not really doing anything when I'm shortening here to negative, either of them, and it is a problem. Yep, I don't know what to say. I really don't know what to say. I'll try to repair it, because this is the only option that I have, and if the repairment also fails, then if I don't find a solution, this is it. This is not it, because I'll have to make another board with the discrete components. So plan B, this was plan C, and that was plan B, or vice versa, whatever. But yeah, the next plan is to use discrete components. I have to reset it again, somewhere here, positive, and you can see it's running fine. Yeah, it's a problem. It's a big problem. I don't know if I can resolve it this time. I don't know if I can repair it. I will try, but I don't think so. Yeah, thank you very much.